Hi there. So we're going to go ahead to verify to solve the following problems. Now what the question says is that we should verify that the vector x is a solution of the given system. Now this is a given system. We're given three systems A, B and C, and then we're told that we should verify that the x that we're given here is a solution of this linear system here. And then we're also told to verify that the x given here is a solution to this linear system here. We're also told to verify that the x given here is a solution to this linear homogeneous system here. So how we are going to go about it, we're going to start with the first question, which is A, to verify that the x given here is a solution of this linear system here. So let me start with question A. Now for question A, I want to show that x equals 5 cosine of t e to the power t. That's the first row. And then given the second row, I want to show that the x given by this column matrix is a solution of this linear homogeneous system. Now the very first thing you want to do in trying to verify that this column vector is a solution of this linear system is to rewrite the linear system in matrix form. Now what we're given is, so let me start by writing the solution. So we're given the x dt equals minus 2x plus 5y, and then we're given the y dt equals minus 2x plus 4y. So now how then do we go about this? Now the very first thing is, when you write this in matrix form, is like you're having what you have here. This is x prime equals then a coefficient matrix, that is all the coefficients you have here, they're going to go into the matrix, the coefficient matrix. So you have minus 2, you have 5, then minus 2, and then you have 4, then multiplied by x. So you note that the x we are using here, our x, is a column vector x, xy. So we shouldn't forget. So now we have our system in matrix form, so which I'm going to write out. So what I want to do is that I want to verify that x given by this, now the x we're given is x equals, maybe I should use a different color for that. So we have 5 cosine of t times e to the power t. So that's going to give us 5 e to the power t cosine of t. And then we have e to the power t times this. So we have e to the power t times 3 cosine of t minus sine of t. So this is what we have here. This is my x, and I want to show that x given by this is actually a solution of the homogeneous system, that is this homogeneous system. So how do I do that? Now if you look here, my left hand side is this, so that is my left hand side. So a very easy way to show that x given by this is a solution of this homogeneous system is to show that the left hand side equals the right hand side. Now for the left hand side, I have x prime. So given this x, so let me find x prime. So for my left hand side, my x prime is going to be the derivative of each of the entries in the column matrix. So I'm going to start by finding the derivative of this. So using this, we're going to use the product rule, because we observe that there are two things multiplying themselves. So applying the product rule there, we're going to have 5 e to the power t cosine of t minus, because the derivative of cosine of t is negative sine t, minus 5 e to the power t sine of t. And then similarly to, we apply the product rule here, we find the derivative of the next row, and then we have e to the power t into 3 cosine of t minus sine of t, then plus e to the power t into minus 3 sine of t minus cosine of t. So that's the derivative of these two terms that are multiplying themselves. And then when we simplify this, what we would have is So we still have the first row still stays the way it is. That's 5e to the power t cosine of t minus 5e to the power t sine of t. And then when we simplify what we have here, just algebraically collecting like terms and simplifying them, what we would have is e to the power t, factor that out, into 2 cosine of t minus 4 sine of t. Now this is what we'll have for the left hand side. Now the next thing I want to do is I want to check the right hand side. This is my left hand side. I've gotten a value for my left hand side, so let me check for my right hand side. So my right hand side is going to be the coefficient matrix times the x I'm given. That's times this x. So now we go to the right hand side. The right hand side. Now for the right hand side, we said that's the product of -2, 5, -2, and 4 times the vector we are given to verify, which is 5e to the power t cosine of t, then e to the power t into 3 cosine of t minus sine of t. So when we multiply this out, what we would have is this times this. That's going to be my -10 e to the power t cosine of t plus then 5 times this, 5e to the power t into 3 cosine of t minus sine of t. And then this times this, so we have a -10 e to the power t cosine of t plus then 4 times this, so we have 4e to the power t into 3 cosine of t minus sine of t. Now this is what we have, and then when we simplify all that we have here just by doing the normal algebraic simplification, what we would have is 5 e to the power t cosine of t minus 5 e to the power t sine of t. And then when we simplify all that we have here too by collecting like terms, we would have 2e to the power t cosine of t minus 4e to the power t sine of t. Now this is the same thing as 5e to the power t cosine of t minus 5e to the power t sine of t into, so we could bring out e to the power t out here, so we would have e to the power t into 2 cosine of t minus 4 sine of t. Now what you observe is what we have here for our right hand side, if you compare it with what we have here for the left hand side, you'd observe they are the same thing. This is 5e to the power t cosine of t is the same thing here. 5e to the power t, -5e to the power t sine of t is the same thing here, and then this is the same thing as this. So we have been able to show that the left hand side, equals the right hand side, and then it's proved. We have proved it, and then that completes the problem.